All right, since we are all ready and Denny's finally here, thank you, Denny. We missed you. Okay, all right, class.
Yes.
Thank you. All right, Denny, you all right? We did miss you. It's not the same without you. It's really not. Okay. So anyway, all right. Related rates with this pool. Now this one right here, rectangular swimming pool. So if I'm looking at it top down, it is a rectangle. Like this, right? Top down, that's what it's going to look like. With 10 meters, 5 meters wide. Okay? And so the depth is where we're going to actually have the most issues with this because it has a depth of 3 meters on one side, 1 meter at the other end. So this pool has a deep end and a shallow end. And 1 meter is about 3 feet. So yeah, there's a shallow end right there. So I'm going to do a cross section of this. So the cross section is going to look like this. So on one end over here, this is 1 meter. And over here, on the other end, is 3 meters. Okay. So there's my pool. This distance across here is going to be my 10 meters. Okay, there we go. So now that we have this set up, so I have over here I have a trapezoid. Over here I have a rectangle. And then this is going to be a volume. And then the volume problem is going to be two different problems together. Because we have a volume of the bottom piece here and the volume of the top piece. Okay? So we would actually be having two different things. So there is going to be rates of change on this, and they change depending on which one, where it's at. So if it's down in the bottom 2 meters, there's a different rate of change because as water starts filling up here, it starts slowing down because as we keep putting more and more water, that means it's spreading out more and more, so it's actually not going up as fast. Once I get further and further up, it's slowing down as I get to the point, but then when I get to this point right here, when I start filling up water into the pool, it's all the same shape, so it's going up at a constant rate. So the rate that it is filling up is going to be a constant rate at that point. Does that make sense? Kinda? Okay, hopefully. Alright, so then I'm going to have a couple different things. Let's go continue reading here. If water is pumped into the pool at the rate of 300 liters per minute, at what rate is the water level rising when it is 1.5 meters deep at the deep end? Okay, so now I know it's going to be a volume problem. Okay, since it's going to be a volume problem, so for the bottom piece, it's going to be my length times width times depth. But the problem is with the depth, it changes, doesn't it? Okay, so since it's changing, it's going to look kind of like a triangle here for my depth. And this is going to be my length, and this is going to be my height. You guys agree? Because my volume just not length times width times height. It would be that if it was a perfect rectangle for the entire pool. but this one changes over time. So as it is increasing there, I know that for this area down here, so the area of this is actually 1/2 length times height. Yes, no, maybe?
Yeah.
Okay, so that's just the area of this. Now, volume, isn't it just area? It's the area times the thickness, isn't it? So if I have a cylinder, I have the area of the bottom times the height or times the thickness. So when I'm looking at each one of these things, I could say, hey, the area of this times whatever my thickness is. And in this case right here, it would go three-dimensional right back here, right? Look at that, 3D. And so as it's going back, this would be my 5 meters going that way. Maybe. Hopefully. Okay, so I'm gonna have to rewrite my volume problem because I don't have just like a regular height. So my volume, can't use this one here because my volume is going to be 1/2 length times height times width. And that's just for the bottom portion. It's not including the top portion. So if I go back to my word problem here, because I'm looking for, so right here where it changes, this right here is 2 meters to this point here. And I'm looking for when my height is 1.5 meters deep. So now I'm going to go through and back to this page. I have this, I know my height has to be 1.5 meters. So there's something I have to plug into my formula. So my height is going to be 1.5 meters. What else did they give me? Did they give me a volume?
No.
They gave me,
A rate of change.
okay, if the water's pumped in the pool at 300 liters per minute,
Oh.
water's being 300 liters per minute. So that's going to be my volume there. That's an L. D. Come on. There you go. Now, what else do they give us? And we're solving for, going back, at what rate is the water level rising? So, water level rising is going to be my H, right? My dH dt.
Yeah.
So that's what I'm looking for. All right, so let's go through and actually find a couple other things from this. If the height is going to be 1.5, the height is going to be 1.5. Okay, I'm going back to this formula over here. If the height is going to be 1.5, I could try to figure out what it would be if I could actually find some of these other things. So I know the width is going to be 5. Is that going to change? Say no. There's no change in that. So if I leave the W in both of these formulas, I would end up with a dW dt, right? Okay, since W is a constant, let's replace the W now with 5. Okay, so now I'm down to just L and V as variables.
Oh,
Okay, because I have L. Okay, I have to find L. I know what L is, right? So we said L is right here. It's going to be the length, which is going to be just 10. So now I know what that is. But now, because this is increasing at a rate, it's going to be a ratio. So as the height changes, isn't the length going to also change? As the height changes, the length is also going to change. So as I do that, I know that there is a ratio of my length to height, or height to length. Because I got to figure out what it is. They are proportional. Do I know what the height is supposed to be, though?
1.5.
1.5, right? My height is supposed to be 1.5 over, I don't know, but I can figure it out. So with that ratio there, so I can replace one of my variables. So it's going to be x h is equal to 1.5 L and what else do we know? We know the height is supposed to be 1.5. Wait, hold on. I gotta go back and double check this one so I don't screw this one up, because I keep screwing up on writing it out. LH, there we go. Oh, I put in the wrong numbers, that's why. So I do have the ratio. But I plugged in the wrong numbers. Because I know my length is 10. So my height over length, my length is 10. And my height that goes all the way up to there for the whole thing is supposed to be 2.
Wait, where did you come
From my drawing
from?
right here. So I'm only using this triangle here, because if I use the whole thing, then it doesn't actually work. So I have the ratio of height to length right there, because as the height goes down, the length also changes. So I don't know what the angle is. I could figure out the angle, and we could actually do some trig there. But if I add some trig in there, I might end up actually having a theta somewhere. But I don't have any thetas. Okay, so now that we have all that set up, I have the length, the height. So this is going to be 10h is equal to 2l. And by doing this, I could actually get rid of my l by both sides by 2. I get 5h is equal to l. Did I confuse you? Yes, no, maybe? Denny? So now, by doing this, what happened to my L?
It's by itself.
Okay, it's by itself, but now what can I do with the L? Can I get rid of it? Say yes.
Yeah.
I can get rid of it, right? And the reason why I want to get rid of it, because, is my L changing?
Yeah. No,
Look.
no, not the.
Okay,
The
so
top
not
one.
yeah, not the top one right there, right? So, in my problem over here, my volume problem, I now can get rid of my L and replace it with another H. And so when I do my derivative, I am only going to have H's in my problem. So I get V is equal to 1/2 times 5 times 5H times H. Maybe? Hopefully. So now let's put it together. And that's going to be my volume is equal to 25 over 2H squared. Take the derivative, so my dV dt is equal to 25 H dH dt. Now can you see why I wanted to get rid of the W, get rid of the L? I only have what I need here. So I was looking for the rate of change for the height, but I was given the rate of change for the volume.
Wait, did you do the derivative?
Yes, I did. That's why it says dV dt. I took the derivative on each. You ready?
Yeah, I
Oh,
thought
okay.
you did square it. I'm like, oh yeah, it's over 2.
Okay, so now let's plug in the values that I have. But one other thing before we get too far into this, 1,000 liters is equal to 1 meter cubed. That's going to be important. Because we're going to have to convert liters here in a moment. So, going back to my problem of what I have, it says that it is, my dV dt is 300 liters per minute. And then if I turn that into meters cubed, because my problem only has meters, right? Only has meters, so this would be what? Divided by 1,000.
0.03.
0.3. Just 0.3. Okay?
Oh, okay, yeah, 0.3.
Okay, 3/10, 0.3. Okay? There you go. So 0.3. So I'm gonna have is equal to 25. My H was 1.5. And then I have dH dt what's that? That was only 25 plus 12.5, 37.5. I don't know. I'm kind of making this up as I go. What is 25 times 1.5? gave you guys calculators, right?
Yeah, I do, and I'm not for
Oh, you're not the only one. I blame Denny. What happened, Denny? Denny was the goat. Denny got sick and fell off. Is that what it was? We gotta get you back on the goat. Is it 37.5?
Yeah.
Okay, good. Wow, okay. So I'm still trying to get my DHDT by itself. Divide by 37.5. So 0.3 divided by 37.5.
0.008.
So you're saying that GHGT is equal to 0.008?
Yeah.
Is that what you said? And what are my units? This is the rate of change for what? What's DH? Height, right? Okay. So the height is going to be a linear, isn't it? I know this was a volume problem, but I'm only going to refer to the height on this one. So it's not going to be a units cubed. It's just going to be meters. And since it is a rate of change, it changes per what? Minute. Does that make sense? Hopefully. So I'm kind of glad I actually saved this one for just being, one problem. Just class with just one problem right here. All right. Hopefully everyone feels pretty happy about this, and not implying that I'm not happy that people haven't started the homework. Okay, I know you guys got other work, but come on. You know what? This is, if you're not practicing it every day that I give you a little bit of something, then it's not going to be beneficial, because you lose part of everything that I say. So they say if you don't practice it, you lose half of what you've learned the day before, if you don't practice it. So, all right. Okay, let's get to work. And again, I try